Have you ever pondered the possibility of life existing beyond Earth, perhaps under the icy surface of a distant moon? It's a question that has captivated the minds of humans for centuries, sparking our curiosity and fueling our exploration of the cosmos. As we gaze into the vast expanse of the universe, we can't help but wonder if we are truly alone. Now imagine venturing far beyond our home planet, beyond Mars and the asteroid belt, to the ringed giant, Saturn. Orbiting this gas behemoth is a small icy moon named Enceladus. Unlike the barren, rocky moons we're accustomed to, Enceladus is unique. It's wrapped in a thick layer of ice, and beneath that ice, we believe, is a global ocean. But what makes this ocean so fascinating is the prospect of what might be lurking within its depths. Could it be a habitat for life as we don't yet know it? What if we told you that this small moon might hold secrets to life as we know it? Scene script: Enceladus, a small icy moon orbiting Saturn, presents an intriguing mystery for scientists. With a diameter of just over 300 miles, Enceladus may be tiny compared to its planetary parent, yet it commands a monumental interest. This moon is not just a ball of ice and rock in the cold, dark void of space. It's an enigmatic world, with a surface that sparkles like fresh snow under the distant sun, making it one of the brightest objects in our solar system. The icy exterior of Enceladus is not just for show, it holds a secret that has caught the attention of scientists worldwide. Geysers! Yes, you heard it right, geysers on a moon! These aren't your typical Yellowstone geysers, though. These are massive plumes of water vapor, ice particles, and simple organic molecules erupting from the moon's south pole, reaching heights of nearly 100 miles before raining back down on the moon's surface. These geysers are thought to be connected to an even more extraordinary discovery, a subsurface ocean. Hidden beneath the icy shell of Enceladus, scientists believe there lies a vast ocean of liquid water. This isn't a small puddle we're talking about, but an ocean that may be global and could be deeper than any on Earth. Now, why is this exciting? Well, wherever we find water on Earth, we find life. So the existence of a subsurface ocean on Enceladus raises the tantalizing possibility that life, as we know it or as we don't, could exist there. But finding water isn't enough. To support life, Enceladus also needs the right chemical ingredients and a source of heat to keep that ocean from freezing solid. And the evidence is starting to suggest that both of these might be present. The discovery of a subsurface ocean on Enceladus has sparked a new wave of scientific curiosity. As we continue to explore our solar system, the enigma of Enceladus remains one of the most compelling reasons to keep looking up and wondering what else is out there. To understand the possibility of life on Enceladus, we first need to understand the fundamental requirements for life. Now, what are these requirements, you might wonder? Well, they are surprisingly fewer than one might expect. 3 basic ingredients make up the recipe for life as we know it: water, an energy source, and organic compounds. Let's start with water. It's the universal solvent, the medium in which all biochemical reactions occur. It's essential for life as we understand it. Now, Enceladus, this icy moon of Saturn, is believed to harbor a vast ocean beneath its frozen surface. The geysers spewing from its south pole, observed by the Cassini spacecraft, are evidence of this subsurface ocean, making Enceladus a place of interest in the search for extraterrestrial life. Next, we need an energy source. Life on Earth is predominantly solar-powered, but on Enceladus, where sunlight barely penetrates the icy surface, the energy source is likely geothermal, generated by the gravitational pull of Saturn, causing tidal heating. This heat could provide the energy necessary for life. Lastly, organic compounds, the building blocks of life. These compounds, made up of carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, are necessary for creating life's essential molecules like proteins and DNA. Excitingly, recent data from the Cassini mission indicated the presence of complex organic molecules in the plumes of Enceladus, suggesting that these building blocks could indeed be present in its subsurface ocean. So we have water, an energy source, and organic compounds, all the fundamental ingredients for life. Enceladus is ticking all the boxes, and it's doing it with a certain flair that's hard to ignore. But as with any good mystery, there's always a twist. While it's true that Enceladus has shown signs of these requirements, it doesn't necessarily mean that life exists there. It simply means that the conditions could be right. The presence of these vital ingredients on Enceladus raises the question, could life exist there? And that's a question we're still trying to answer. Over the years, several intriguing pieces of evidence have been gathered about Enceladus. Let's start with the detection of organic molecules. These are complex compounds that are considered the building blocks of life as we know it. They've been found in the icy plumes spewing from Enceladus's subsurface ocean. This is a significant discovery because these molecules are the exact ones we'd expect to find if life was present. Next, we have the presence of heat from the moon's core. This is not some lukewarm heat we're talking about. It's enough to keep a subsurface ocean from freezing solid despite the frigid temperatures of space. This heat is thought to be created by tidal forces as Enceladus orbits Saturn. Heat, as we know, is a vital component of life. It's what helps drive the chemical reactions necessary for organisms to grow and reproduce. And then there's the discovery of salt and silica particles in the moon's plumes. Salt suggests that the ocean is in contact with the moon's rocky mantle, making it possible for minerals to leach into the water. This is important because minerals provide nutrients that life forms can use. Silica, on the other hand, is thought to form when hot water interacts with rocks. This suggests hydrothermal activity, similar to the black smokers on Earth's ocean floor, which is known to support diverse ecosystems. And let's not forget about the detection of molecular hydrogen in these plumes. This could be a potential energy source for life. It's like finding a fully stocked pantry in an unexplored wilderness. Each of these discoveries on its own may not conclusively point to life, but together they paint an intriguing picture of a moon with the right conditions for life to exist. A place where heat, water, and organic compounds come together in a tantalizing mix. The evidence points towards an environment on Enceladus that could support life. The exploration of Enceladus is far from over. The journey has merely begun, and the road ahead promises to be filled with thrilling discoveries and enlightening revelations. In the coming years, the world's leading space agencies have charted ambitious missions to this icy moon of Saturn, the primary aim, to delve deeper into the tantalizing possibility of life beneath the icy surface of Enceladus. NASA, for instance, has a mission in the pipeline known as the Enceladus Life Finder, or ELF for short. This mission aims to further investigate the plumes of water vapor erupting from Enceladus's south pole, which we touched on in the previous scene. The objective here is to look for complex organic molecules, essentially the building blocks of life, to support the hypothesis of a habitable environment deep within Enceladus. Similarly, the European Space Agency has its eyes set on Enceladus too. Their proposed mission, the Enceladus Explorer, intends to land a probe on the moon's surface. This audacious endeavor will enable us to study the surface and subsurface of Enceladus in greater detail, thereby bringing us one step closer to unraveling its secrets. These missions are not merely scientific expeditions. They represent the collective curiosity and indomitable spirit of humanity. They echo our primal instinct to explore the unknown, to seek answers to questions that have eluded us for centuries. However, let's not forget that these missions come with their share of challenges. The harsh and inhospitable conditions of Enceladus make it a tough nut to crack. But if history has shown us anything, it's that we humans thrive on challenges. We rise to the occasion, we innovate, and we overcome. The exploration of Enceladus is a testament to our unyielding quest for knowledge. Each mission, each discovery brings us closer to understanding our place in the cosmos. As we continue to explore Enceladus, we might be closer than ever to answering the question, are we alone in the universe? Only time will tell. But one thing is certain, the journey is going to be one hell of a ride. Let's revisit the key points of our journey to Enceladus. This icy moon of Saturn, a new frontier of space exploration, intrigues us with its enchanting enigma. Beneath its frozen surface lies a vast subsurface ocean, a potential cradle for alien life. This ocean, warmed by Saturn's gravitational pull, holds the basic building blocks of life: organic compounds, water, and heat. Our scientific endeavors have presented compelling evidence, with spacecraft detecting plumes of water vapor and icy particles spewing from Enceladus' south pole. These signs suggest the presence of hydrothermal activity, an environment where life as we know it could potentially thrive. Looking ahead, the future of exploration promises exciting prospects. With missions planned to further investigate this enigmatic moon, we hope to unravel more of its mysteries. While we cannot yet confirm if life exists on Enceladus, the possibility is fascinating and continues to drive our exploration of the universe.